Okay, we're going to go over chapter 8, which is process management, lean, and Six Sigma. So if you'll open up the PowerPoint and have a look at that, we're going to start on the slide number 4 that says introduction. So I just want to talk to you a little bit about quick response and what that means. So that quick response is a way to get manufactured goods to the client or the customer as quickly as possible. That's why it's called quick response. JIT stands for just in time. Just in time basically says you want to have something become available to you as soon as you need it, but not any sooner. So you don't want a gallon of milk delivered to your house on Monday if you're not going to run out until Friday, but you don't want it to come on Saturday. You don't want it to come after you're already out of it. Keiretsu is making relationships. This is another Japanese term. There's a lot of those in this chapter. A Japanese term that talks about building relationships between your suppliers. So all these things kind of came together and they are known as lean production, lean manufacturing, lean thinking. They're all the same. Toyota was very key in doing this, and they were Toyota built it based on what they observed at Ford. So on the test, you'll see a question about Ford. That's the correct answer. So Muda is waste. You'll see some information on that on another slide here. Kanban basically says, send me more stuff to the production floor. It's a way to build a set of things. So if you're going to make 10 sandwiches, you know you need 20 pieces of bread, a jar of peanut butter, a knife, a jar of jelly, and 10 Ziploc bags. All that would be in one container. That's called a Kanban, and then that would come to the production floor, and maybe when 5 of those were completed, a new Kanban with 10 more things to make 10 more sandwiches would come to you. We're not going to talk about SPC, you don't need it. Poka-yoke is a way to make sure that it's impossible to do something the wrong way. So for example, if you want to only place something horizontally into the assembly, maybe there's a fixture on the table where if you try to put it vertically, it won't fit. So you know you have to set it in there the right way. And Yokoten is a way to share best practices. We are going to talk about all these things, but reduction of waste, continually finding better ways to make the process improve, figuring out how material flows through the organization. You want to make sure everything comes into one side of the warehouse and that finished goods ship out the other side generally. You don't have things crisscrossing the warehouse because it's a waste of effort. And then making sure that your partners are integrated throughout the supply chain. So we've talked about that many times. Cross-training, everything on this, I didn't put any of this on your test, but I just want you to know what this is about. You can read through slide 8. These are the main elements of lean. I would know these and I would have this slide ready when you're ready to take your exam. So we talked a little bit a minute ago about waste reduction. So Muda is waste. That's a Japanese word. So there are 7 wastes according to this lean philosophy. If you make too many, so overproducing. If you have to wait, so if my part of the production process takes 3 minutes and your part takes 4, then you're behind me. You're not going to ever get me a part. I'm going to stand around waiting for 1 minute every single time I finish making something until the next one comes to the assembly line. You want to balance so that everybody is making the same thing. One of the ways they do that is if mine takes 3 minutes and yours takes 4, maybe there's a couple of me and only 2 of you, or 3 of me and 2 of you, so that there's always a free flow. Moving things back and forth in time is a transportation. You do not want that. It takes way too much time. You don't want to move things around too many times. So you wouldn't want to pack that lunch, put it in the upstairs, and then know that you have to go get it, bring it downstairs, put it in the refrigerator, take it out of the refrigerator, go back upstairs and put it in the backpack, and then bring the backpack downstairs to leave for school. Completely waste. So all that transportation of goods throughout the warehouse, very wasteful. Over processing, there's no need for me to gift wrap that sandwich once it's in a Ziploc bag. That's unnecessary, right? We don't need it to be perfect. We just need it to be the way it needs to be. Having too much inventory because the bread would go moldy in this scenario. Moving things around. If you said, we're going to put the peanut butter on the bread, but to get to the jelly, we have to walk around the island 3 times. You don't want to do that either. And then anything that causes scrap, so wasted product or wasted if I was putting the peanut butter into there and I spilled it, things like that. So that's all. So that's on slide 11. On slide 12, you'll see there's 5 words here in Japanese that all begin with the word S. In English, we have kind of made a way to make this also be the 5 S's in English words. So sort, set in order, sweep, standardize, and self-discipline. You need to know this for your test, but this is another aspect of lean production. Okay, we are moving now to slide 14, talking about manufacturing cells. I'm going to show you a U-shaped one on slide 15. So the idea here is that the first thing in the assembly process would start there like at 8 o'clock, so that lower left-hand corner, and then everything would move through and go out. So everything's going in one direction and it's staying consistent. I didn't give you any questions about this. I do want to talk to you about small batch scheduling, and I'll show you this, and I talked to you a little bit earlier about Kanbans, but let's look at slide 19. You can see that if we make a bunch of short lots, we have a lot of flexibility. If we go to the bottom, if we do all the A's at one time, it takes a lot longer because it takes us a long time to get all the material set up to make that many item B. We can only do 3 product changes in the same time that we can do 9 product changes. So it gives us a lot of flexibility if we build a small number at a time quickly. This is the Kanban system I just talked to you about and said if you had the stuff to make 10 sandwiches, when you got maybe to 5 sandwiches, it would give you a whole nother kit, another Kanban with that ready to come to the production floor. You do not need to know any of this. Looks like math. Let's go to slide 24. As we've talked about, this book, of course, has to have lean green. Got to talk about green. So green is about making sure that we are managing the environmental impact of anything that we're doing from a production standpoint. Six Sigma is something that you'll hear a lot, and definitely you need to know that Six Sigma and lean are not the same. So Six Sigma is a quality designation. That means, if you'll count there, 99.999, and then 66 is how it would round up to another 9. So that means if I make 1,000,000 parts, what is the likelihood that 99.99966 of those parts will be defect free? And so Motorola started this. I think I put that on your test as well. But it basically is a way to use statistics to determine quality. It's very similar to how a batting average is calculated. If you think about someone might only bat 40 times, but they do the math to pretend that they had batted 1,000 times, and they say, if he had batted 1,000 times, how many times would he have gotten a hit? And they do that math. It's just a simple ratio, but they do it. You learn this in algebra in high school. But that is a similar concept here. You're figuring out, if I were to make 1,000,000 parts, what is the likelihood that 99.99966 of them would be defect free? And so this will give you some information about how they calculate this from the standard deviation. You don't need to know this. All this would be done by a quality management system software that you would have in the production facility. So you hear people talk about Lean Six Sigma. That's the concepts of lean that we talked about, like eliminating waste, continuous improvement, and married with the quality idea of Six Sigma. You'll hear people talk about Kaizen. Kaizen is continuous improvement. So Lean and Six Sigma are complementary to each other. They are not competing, but they're not the same thing. So you just need to know that. W. Edwards Deming is what many people call the father of quality. And so Deming said a lot of things. The most important thing I want you to know here is number 8, which is drive out fear. If you establish the fact that employees are not afraid to call out a quality defect, they're not afraid to say, hey, we need to stop the manufacturing process, we think we have a problem, then you have empowered employees that can keep you from continuing to make bad parts or continuing to add value to parts that are going to have to be reworked. So if I pulled the bread out in my lunch example and I noticed that the bread was moldy, I wouldn't want to waste putting peanut butter and jelly on it and waste a baggie by getting it dirty only to have it go to that final quality inspection and have them say this doesn't pass because the bread is moldy. If the bread is moldy, the person who first touched the bread should have noticed that and said, stop, we have a bad loaf of bread, let's get a new loaf of bread, and that would have saved the cost of the baggie, the peanut butter, the jelly, and the person's labor making the sandwich. So it's a much better way to do that, is to have the employee with the power to stop the production line. Crosby is another one. So Crosby says, We can say that something is good quality or bad quality, and it's ambiguous. But if we want to define what quality really is, it should be conformance to the requirements. So I can say that a gallon-sized Ziploc bag is not good quality, but maybe I'm trying to put my family's garbage in it for the week. Well, it is perfect quality for what it's designed for. It meets the requirements as long as it seals and it protects from freezer burn, but it's not designed to conform to the things that a trash bag would be for your family. So what Crosby says is that quality is about what are the requirements, what were the specifications, and does the product meet it? If it does, it has good quality. And that the performance standard should be there should never be a defect. That is unreasonable. There's always going to be some, but that the standard should be you're always striving for zero defect. You'll see this chart on slide 31 talking about what Crosby thinks. This is definitely on your test. And then urine. Urine says if you plan and you have quality control, then you will always know where you stand with quality, and that the managers should figure out what is our goal, where do we want to improve, and then are we measuring that? So I think I've talked to y'all before about if I never had a scale, I would never know if I lost weight. You have to measure the quality to know if you did well or not. I didn't put anything on the test I don't believe about the Malcolm Baldrige Award, but you just should know at a high level, this is very, very, very expensive for companies to apply for, but very prestigious. If you win this, it's very difficult to achieve. Malcolm Baldrige, they only award one every year, and it's very expensive to apply. But it's all about having very stringent quality processes across the business. So we've talked about ISO 9000 and ISO 14000 in the past, but that's again brought up in this chapter because we're talking again about quality in the environment. So the DMAIC is, you probably have seen something similar to this in your if you've worked in a business, we're on slide 36, but defines the process, measure it to see how you're doing against the process, analyze, do we need to make improvements? If we do, what should we do? Make those improvements, and then put in some controls so we make sure we stay. So if we go back to my diet example, we're going to define I need to lose weight. We're going to measure how much do I weigh today, how much have I weighed over maybe a 30-day period, and we're going to analyze what did I eat, did I get enough exercise, am I getting enough rest, am I taking vitamins? I'm going to say I didn't get enough rest and I'm not getting enough exercise, I need to improve. I'm going to set a plan for that, and then I'm going to set a control maybe where I'm going to track all those things so that I can continue to measure that over time. And this cycle then would go back from control back to define and start over again. This is a little bit more information on that on slide 37. You don't need to know the specifics of each belt, but you should know that if you're going through Six Sigma training, you'll hear people talk about that they're a green belt, they're a black belt, they're a master black belt, similar to karate. And this is how highly skilled and how highly trained you are in Six Sigma practices in a manufacturing environment. Okay, so this is going to be something that may be a little bit new to you. So flow diagrams are like a flow chart that you have seen probably lots of times. I'm going to talk to you about what check sheets and Pareto charts are and what we call either a fishbone or an Ishikawa or a cause and effect diagram. So this is a process map for a customer flow at a restaurant. So you can walk through all these things, but let's say that I'm the manager at this restaurant and I say, what are my problems? So I've said, we had this many people with a wait on Monday, and I just check them off. Okay, so just get a quick glimpse of this, and we've added up in the far right column what the percentage of each one of these is. So if we look at this chart, we would see that long wait is the 26% of all the problems. If we eliminate just that one problem, a quarter of all the problems we have go away. So we don't want to focus on, say for example, bad table, because it's only going to make 4 people out of 100 happy. If we can fix the long wait problem, we've made almost 27 people out of 100 happy. So this is called a Pareto chart. So this is named after a gentleman named Vilfredo Pareto, who invented this. And what he said was, if you can figure out what the biggest problem is and attack it first, that it makes you're getting vast improvement more quickly. If I would have solved cold food, bad table, too expensive, and bad food, all of those are not as much of a problem added together as long wait. So this is showing on the weekend, it looks like Friday and Saturday, we have an even more of a problem than during the week. So those are our busy nights. That would make sense. So this is a concept called they call this a fishbone diagram because it kind of looks like a scaled fish. They call it an Ishikawa, which is named after a person, a Japanese gentleman who worked through this, or you can call it a cause and effect. So in the box on the middle on slide 44, you'll see a long wait. Long wait means that's our problem. And what we're going to do with that first arrow is we're going to say why. And so our 4 reasons we said why are machinery, material, methods, and manpower. So if we say machinery, why is machinery causing it? Well, the credit card scanner breaks. Well, the washing machine breaks. Why does the washing machine break? Because it needs frequent maintenance. So you can see every time we ask why, we add another arrow and we point this near. This allows us to figure out what do we need to do. So if we say we need automated cooking bays and more frequent maintenance on our machinery, a lot of these problems could potentially go away. If we say we need to figure out why we're having late deliveries of material, we might be able to solve some more problems. So this gives you a way to continue to ask why on every one of these until you can figure out how to prioritize what to do to make it better. You don't need to know this. Okay, so let's go to, this is a bunch of math you don't need to know. Let's go, that's the end of the chapter. So I'm going to stop recording this and we're going to go to chapter 9 in the next video.